Lake Ladoga, presented by Natalie Hunt. Let's begin our look at Lake Ladoga by first learning about its physical characteristics. Lake Ladoga is located in western Russia, north of St. Petersburg, and southeast of the Finland-Russia border. Lake Ladoga is the largest lake in all of continental Europe and the 14th largest lake in the world based on its surface area of over 17,700 kilometers squared or 6,824 miles squared. The lake was formed by natural processes. Over 10,000 years ago, glaciers receded from the region as the last ice age ended. Most of the area was formerly sedimentary rock, which was scraped away by the glaciers. As the ice receded, the depression that was created by the ice was revealed and filled with melting glacial waters. The right-hand figure shows what some estimates suggest Ladoga may have appeared as shortly after the glaciers retreated. This figure shows the various limnetic zones of Lake Ladoga, as well as the major rivers and population centers that surround the lake. These zones are divided up based on depth. Area 1 is considered near shore with depths that are less than 15 meters. The second area is the profundal slope with a depth between 15 and 52 meters. Area 3 is the profundal zone with depths between 52 and 89 meters. The last zone is the ultraprofundal zone with a depth greater than 89 meters. The maximum depth of the lake is 230 meters or 755 feet. As of 1996, the most recent estimate of the lake's volume is 837 kilometers cubed. This data was generated using the latest computational methods and is more accurate than previous estimates. Ladoga is fed by three main tributaries, the Sever, the Vaksy, and the Volkhov rivers, while the Neva River allows the lake to drain into the Baltic Sea. The estimated retention time for Ladoga is 11 years. Estimates place the total catchment area for the watershed of Ladoga to be around 258,000 kilometers squared. Latest measurements of water transparency show that Ladoga typically fluctuates between 1.8 and 3.9 meters in Secchi depth per year in open water areas. As the above figure shows, the water transparency within the lake has decreased over the past several decades due to increased eutrophication. Now that we have an idea of what the lake as a whole looks like, let's take a closer look and analyze some of the chemical characteristics of Lake Ladoga. Latest measurements of Lake Ladoga's dissolved oxygen content suggest it fluctuates between 9 and 15 grams per liter based on the time of year. Some estimates have suggested that the concentration of phosphorus has increased 2 to 5-fold since the 1960s in Ladoga, with the most recent estimates of the lake being between 12 to 15 micrograms per liter. Research has also shown that phosphorus may be the limiting nutrient for bacteria and algae within the lake. The above figure measures phosphorus concentrations based on the different limnetic zones as well as the lake as a whole. In 1993, the mean value of phytoplankton biomass was 1.3 grams per meters cubed. Between 1984 and 1989, the mean concentrations of chlorophyll A was between 1.6 and 2.0 micrograms per liter. Ammonium concentrations as of 1994 were between 0.04 and 0.24 milligrams per liter. In the 1960s, Ladoga was considered by many to be a very oligotrophic lake. In the past few decades, the lake has become more eutrophic. This change is attributed to increased sources of human and industrial pollution. Due to its large size, many researchers still struggle with classifying Ladoga into one category of trophic state. At its deepest point, it could still be considered oligotrophic, whereas in its more shallow coastal areas, it could be considered eutrophic. As a result, most researchers choose to classify it as mesotrophic. This is in part due to the annual primary production, phytoplankton biomass and chlorophyll A concentrations within the lake. Let's get to some of the biological characteristics that make Lake Ladoga unique. Between the 1950s and 1960s, Ladoga consisted of over 380 recorded varieties of phytoplankton, with diatoms making up over 45% of the records. In 1968, over 327 species of zooplankton were recorded. These recorded species included 221 Rotaria, 72 Cladocera, and 34 copepods. Blue-green algal blooms are common during the late summers in Ladoga. This is often attributed to the increased eutrophication of the lake. Year-round, the most common type of algae is filamentous. Research has also identified over 87 species of higher aquatic plants within the lake. Ladoga is rich with fish, with over 47 different species found within it, which include, but are not limited to, roach, carp, bream, zander, European perch, and even the endangered European sea sturgeon. Fishing is a major source of industry for the region and provides locals with a source of income. Overfishing was common and became severe during the late 1950s. Management practices began in 1964 and helped increase populations back to their historical levels, making it possible for locals to continue fishing safely. There are only 5 known species of amphibians and reptiles within the lake. The species of amphibians includes the smooth newt, the crested newt, the common frog, the common toad, and the moor frog. Reptiles include the sand lizard, the common lizard, the slow worm, the grass snake, and the adder. The most interesting mammal that is directly linked to Ladoga is the Ladoga ring seal, pictured on the left. It is an endemic subspecies of ring seal that only exists in this lake and a neighboring lake to Ladoga. Other terrestrial mammals that are common within Ladoga's system are European wolves, red foxes, sika deer, and even American minks, which were introduced in the 1950s. Arguably, one of Lake Ladoga's most important and well-known moments occurred during World War II. Ladoga, while frozen over, was converted into a road by local fishermen and engineers to collect supplies and allow citizens from Leningrad, now known as St. Petersburg, to escape from conflict with the Nazis. In the end, over 1 million tons of food and supplies were brought across the lake, ensuring the survival of many citizens of Leningrad. However, many still died. The first photo on the left is a memorial left by the lake to honor those who died trying to cross it and bring supplies. The second photo on the left is a picture of the first year of which supplies were collected and brought across the lake by horse-pulled sleighs. The picture on the right is an example of the last 2 years of the supply train, where trucks and automobiles were used in place of horses. Currently, Ladoga is most internationally important because its drainage basin is located within both Russia and Finland. As a result, changes that occur within the lake's water quality affect the surrounding countries. Since 1994, Ladoga has become more eutrophic as great loads of sewage were improperly treated and dumped into the water, as well as an increased industrialization of the surrounding areas. Additionally, Ladoga is used as a major fishing resource for the region and has been managed to reflect that. So why should you care about Ladoga? Ladoga is a unique and vital habitat for many species of animals, including but not limited to the Ladoga ring seal. The lake also provides local humans with industry, a reliable food source, as well as a tourist destination which can bring income to the region. If Ladoga is not properly maintained, it could lead to algal blooms and fish kills, which no one wants to be a tourist towards. This could ultimately lead to a loss of a great resource for the region. In conclusion, Ladoga is a very intriguing lake. Its large size and unique wildlife make it an interesting topic of study. In the future, I would like to see more recent studies of even the basic qualities of Ladoga taken. I was hard-pressed to find anything more recent than 20 years ago. I would also like to see any studies at all on the waterfowl or bird populations that rely on the lake. I found it difficult to find a list of species for the lake, let alone how they might be affected by the increasing eutrophication of the lake itself. I hope from this video that you learned a bit more about Ladoga. It is an interesting example of how waterways, even large ones, can be affected by human influences, and I think it's something we need to consider